Okay. Start over. Just kidding.
You can just cut that part out.
Okay, so we decided to do our physics research project over capacitors. Capacitors are essentially components in circuits, just like resistors, and battery, diodes, LEDs, anything like that. Their function is to hold charge, to store energy. Capacitors are comprised of two metal plates, oppositely charged, 1, 2, positive, negative, and in between them, sandwiched in between them, is an electrical conductor called a dielectric. We'll just say that's a dielectric. And of course this is connected to a circuit, and this is essentially what allows a capacitor to hold charge. Capacitors, when supplied with power, they will charge up to a point, and then they will slowly discharge that energy over time. So now Christian's going to explain how they work in circuits.
Well, I'm going to draw a basic circuit with a capacitor here so we can understand how it functions a little bit better. So this is the power source, and then we draw the capacitor here. Capacitor looks similar to the power source, except it has the two lines of equal length. Then a resistor, and in this case resistor is a light bulb. So power is going to travel from the power source, the battery, through the circuit. When it gets to the capacitor is going to charge up, it's going to start storing the energy, and the light bulb is going to light up. When you turn, now normally if you didn't have a capacitor in the circuit, when you turn on the battery, the light bulb will light up, and when you turn off the battery, the light bulb is going to immediately turn off. There's no more power being supplied to it. And with a capacitor, the capacitor is storing energy, so when you turn the battery off, the capacitor discharges all the energy it was storing, and the light bulb slowly dims instead of turning off immediately. Now, capacitors are really important because of their ability to store charge. That's why we're using them. And the amount of charge a capacitor can store is called the capacitance. And to calculate capacitance, we have a couple equations. First one we have is C equals Q over V. C is capacitance, Q is the charge between the plates, and V is the voltage running through the plates in the power source. So, like how we drew earlier, this is what the charge would be, charge between the two plates, and the voltage running through it is that. And this equation is calculated in farads, but farads are really big. Most capacitors don't really store that much charge, so most people convert to microfarads as their unit. And then we have another equation. If you didn't know charge or voltage running through, you could use capacitance equals epsilon sub r times epsilon naught times A, all divided by distance between the plates, D. Epsilon sub r is the dielectric constant, epsilon naught is the electric constant, A is the area overlap between the plates, like if one of these was longer than the other, it's the area overlap there, and D is the distance between the plates there. E sub naught, the electric constant, is the number 8.845 times 10 to the negative 12th, and that's also calculated in farads. It's a pretty commonly used equation. Basically, if you don't know charge, voltage, if you do know the dielectric constant, then you can use this one to calculate capacitance. And there's one more equation. It's not used that much because, unlike the other two that are calculated in farads, this equation puts it in units of CGS or Gaussian units, which are rarely, if ever, used to describe capacitors because farads are just a common thing. So C equals E sub r times times A divided by 4 pi D. A is the area overlap, D is the distance, same as before, E sub r is the dielectric constant. So this one has less variables, but again, it's rarely used for a reason. No one ever talks about it in terms of Gaussian units. So yeah, that's there. Probably won't need to know it that much, but now we can talk about subwoofers.
Alright, so basically the application of capacitors that we chose to talk about with subwoofers. Subwoofers are, in sound systems, you can find them in your car, in theaters, probably there's a subwoofer with your computer system maybe. Subwoofers basically use capacitors very well. I'm not going to draw an actual circuit diagram, but we'll just simplify this. This is your power source, and then let's say you've got this is your amplifier, which is the thing that makes the sound in a subwoofer, and boom, it's making sound. Without a capacitor, the power source is outputting constant voltage, probably a pretty large one, and the subwoofer is essentially requesting a variable voltage. So, in music, when you have, whatever your music, it's kind of all over the place, right? It's peaking, it's dipping. So your subwoofer is requesting different amounts of power at different amounts of time based on how the music is. And whenever the music peaks and you get really, I don't know, strong parts of the music and your subwoofer is requesting a lot of voltage, it's possible that your power source can't essentially provide all that at the same time. And especially when you have other components, say a light bulb or something, connected to the same circuit, if your subwoofer takes priority, your lights are going to flicker or turn off or fail or something like that, because all the power needs to go to that subwoofer. It needs to provide it for those peaks. And it's going to be a very variable and just awkward and not very good, not very functional system. However, with a capacitor, and probably one with a very large capacitance, your power source is going to output a voltage, and it's going to go into this capacitor, and it's going to power up, essentially, this capacitor to a certain max, okay? And your capacitor is going to act as a buffer between your battery and the amplifier of the subwoofer. So when that subwoofer peaks in the music and it requests a lot of power, this capacitor is going to discharge the stored energy enough to where, the subwoofer can function. And your battery isn't going to get damaged, the lights aren't going to flicker, nothing bad's going to happen. And then your capacitor is just going to store that energy right back up, because the battery's always providing power. So that's the main reason, right? So capacitors are good for protecting your battery and whatnot. However, capacitors are also pretty useful when they keep your voltage constant. So in a circuit, this is voltage at 0. You have something where this is a rectified waveform, okay? It looks like this. These humps, these lines, this is your voltage, all right? This is because, in AC current, you've got this going on, it's positive, it's negative, whatever. You have something called a rectifier, bridge rectifier, whatever. It's not important. All you need to know is makes this hump go here, and then boom, it's there. It looks like this now. So this is bad, right? This is real bad. You got your voltage at 0, you got your voltage peaking at 0. It's not good. It's all over the place. You don't want this, okay? But when you have something, a capacitor, right? Capacitor connected to the circuit. Your capacitor charges up with this voltage, and then when this voltage dips down, your capacitor is going to slowly discharge its stored energy. So it's going to slowly discharge that energy, and then, oh look, your voltage is back up, it's going to charge again, and then it's going to slowly discharge the energy when the voltage goes back down, and then, oh, it's going to charge back up, and it's going to discharge. So essentially, this is what the voltage would look like without a capacitor, and this brown line is what it would look like with a capacitor, this is a much more constant, line of voltage, which is good for your system, than this rectified waveform is. So capacitors are really useful for keeping voltage constant, keeping your system safe, keeping your lights from flickering and all this good stuff. And they're a good deal, and capacitance is important. And
one thing I forgot to mention about capacitors, they are limited by the voltage output from the battery. I mean, seems pretty obvious, but if you have a 1.5 volt battery, the capacitor is only going to be able to store 1.5 volts because the battery can't put out more energy than that, even if the capacitor can hold potentially 3 volts. So, yep, that's capacitors. Thanks for watching. Do good on the test. Yeah.
Cool.